Okay, in this video, we're going to solve problems related to rhombus. The way in which we define rhombus, a rhombus, is that it's a parallelogram with all sides equal. Okay, so for this problem, it says find all length in a rhombus or in rhombus A, B, C, D. Okay, so since we know that all sides are equal, we can take two pairs of sides and make them equal, right? These two sides have the same variable, so we can make them equal and try to solve that that equation. So 3b plus 2 will be equal to 4b minus 2. Okay, and we can solve this equation using our usual algebra. So remember that we need to group the variables, so we can subtract on both sides by 3b, right? And this 2 will be gone, and we will get that 2, it's equal to 4b minus 3b is b minus 2. Since we're isolating b, we can add 2 on both sides, and then we know that these two things will cross out, and we will get that 2 plus 2 is 4. It's equal to b. So we know that b is equal to 4. To find the length of these sides, then we know that AB is going to be equal to 3 times the value of b, that is 4 plus 2. 3 times 4 is 12, plus 2 is going to be 14. So AB is equal to 14, right? So since we know that all sides are equal, then we know that all the sides are equal to 14. We can test real quick. For example, CD. So we have that CD, it's equal to 4 times B is 4, minus 2. 4 times 4 is 16. 16 minus 2 is 14, right? So CD, it's equal to 14. Right? So we just test what we already know. You can do the same thing with these two sides and show that the value will be exactly the same. Okay, so let's do another problem. In this problem, we have that in rhombus A, B, C, D, find the measure of angle D. So we're looking for this angle right here. Okay, we know that in a parallelogram, two consecutive angles are supplementary. So we know, or we have expressions for these two consecutive angles. C is expressed with x, and A is expressed with 2x plus 6. So we know that we have x plus 2x plus 6 is equal to, since they are supplementary, if I add them, it's going to be equal to 180 degrees, right? Let's get rid of the degrees for a moment. We know that we can just destroy these two parentheses because this positive sign will not affect anything inside. So we just need to group like terms. So x plus 2x will be 3x plus 6 equal to 180. So now we have this simple linear equation that we can solve using the regular algebra. So to isolate for x, we need to get rid of the 6. So we apply the inverse. This will be gone. 180 minus 6 will be 3x will be equal to 180 minus 6, that is 174. To get rid of this 3, we need to divide by 3 on both sides. Right? So we're rid of this, and we get that x, it's equal to 174. So 174 divided by 3, it goes 5 times. So 15, 17 minus 15 is 2. We bring the 4 down, and it goes 8 times. 8 times 3 is 24. So this is 0, and we know that the answer is 58, right? So x is going to be equal to 58, all right? That's the value for x, not the value for the angle. Remember that we're looking for D. Okay, so we know that opposite angles or pair of opposite angles are congruent in a parallelogram. So if we find this angle A, then we will find D because they are equal. Okay, so we can substitute this value right here in this equation. So angle A will be equal to 2 times 58 plus 6. But 2 times 58 is 116. Plus 6 will be equal to 122 degrees. That will be the value for angle A. So if that's the value for angle A, then the value for angle D will be exactly the same because they're opposite. So 100, this looks like a 9, 122 degrees. That's how you solve this problem related to rhombus. Let's do a 2-column proof. The last problem with 2-column proofs. In this problem, we have that the given is that RSTU is a rhombus, right? And the angle ARU, and remember that I always told you that try to put some colors to the things that are given so you don't forget that you have them. So ARU, this angle here is congruent with BTU, so this angle here. Okay, prove that AC is equal to SB. So we're going to prove that AS, this, let me use a different color that we can see better. All right, this side, AS, is equal to SB, this side right here. Okay, so remember that to prove that two segments or angles are congruent, it's really useful that we think on how to prove that the two triangles, if we have triangles, that the two triangles in which those segments are in are congruent. So in this case, we should prove that, or we should reach first that STB it's congruent with ASR, right? If we know that these two triangles, this triangle and this triangle are congruent, then by CPCTE, we can guarantee that these two sides are equal. But to prove that these two triangles are equal, we need to have side angle side, or side side side, or angle side angle, or if you want, since it's the same, angle angle side, right? If we reach any of these three conditions, then we know that they are congruent. So let's make basically a plan. What we have, all right, let me erase this real quick. What we have, just from the figure, we know that these two angles are congruent because they're vertical angles. So this angle is congruent with this angle, right? What else do we have? Maybe we're able to prove that these two angles are congruent. And how can we prove that? Well, if you notice, angle 1 and angle 6 are opposite, and they are in a rhombus because it was stated since the beginning that it's a rhombus. So from the rhombus, we know that these two angles are opposite, so they are congruent. So this two needs to be also congruent since the whole angle is congruent, right? Well, that's one option. So we already have an angle and an angle. But in a rhombus, all sides are congruent. So this must be congruent with this, right? So if these two are congruent and we have the angles in these corners, then by ASA, then the two triangles are going to be congruent. So now that we have our plan, let's do it. So, well, actually, let's leave this marks here so we know what we already established from our plan. So we have our statements, and we have our reasons, right? Reasons, right? Our first statement is the given RSTU. It's a rhombus, right? And angle ARU, it's congruent with angle BTU, right? This is given, all right? Number two, we know that these two angles are congruent because there are vertical angles. Instead of calling this 4 and this 3, let's call, all right, actually we can call them different names. So this will be 7 and angle 8. So we know that angle 7, it's congruent with angle 8. This is by vertical angles, right? And we also know that since in a parallelogram, in a rhombus, all sides are congruent. We know that ST is congruent with RS. So we know that ST is congruent with RS. This is by definition of a rhombus, right? Definition of a rhombus. Okay, so let me move a little bit up the page. So we already have one angle and a side. So we need to prove that this angle 2 and angle 5 are congruent, but we know that angle 1 and angle 6 are congruent. So angle 1, it's congruent with angle 6. This is because opposite angles in a parallelogram are congruent, right? They're congruent. And since we know by the given that ARU is congruent with angle BTU, then we have this. We know that angle, or let me do it real quick here. I'm going to erase this after the analysis. So we know that angle ARU, or the measurement I'm going to get rid of that symbol for now, just to be a little bit quicker. But the idea is that we're comparing actually measurements. So this is equal to angle BTU, right? But we know that angle ARU, it's the sum of 2 and 1. So angle 2 plus angle 1 will be equal to angle BTU. But angle BTU, it's equal to the sum of these two, right? By the angle addition postulate. So 5 plus angle 5 plus angle 6. But we know from the opposite sides that angle 1, it's equal to angle 6, right? So these two angles are actually the same, so we can cross them out, right? So angle 2 will be equal to angle 5. That's how we get that the other angle are equal. All right, so let's erase this. And we know that angle 2 now, it's equal to angle 6. So angle 2, number 5, actually, let me use white. So we know that angle 5 is going to be, angle 5 is going to be congruent with angle 2, right? Why is this? Because we use the angle addition postulate. We use the given, right? We use the given, the number 1 statement, right? We use substitution, and we solve the equation, right? So now that we have that, now we know that triangle ASR, it's congruent with angle TSB. So triangle TSB. This is by angle, side angle. And number seven, since these two are congruent, now we can say that side AS is congruent with side SB. All right, so SB, or with segment SB. This is by CP/CT. So this is how you prove that the two sides are congruent. All right, review it. Go back and review the proof and check if you can do it in another way, or check how how to make the plan to make the proof. All right. So I hope that this video was helpful, and see you in the next one.